73. That is the number of Microsoft's own GitHub repositories that were taken offline this week. Not by a government, not by a rival corporation, not by a nation-state actor with $1 billion intelligence budget and years of patient infiltration. By a worm. A self-replicating, credential-stealing, supply chain-devouring piece of malicious code named after the giant sandworms in the Dune novels. A name its creators chose, deliberately because, like the creatures it references, this worm moves underground, invisible, through territory that looks stable from the surface. And when it surfaces, the destruction it leaves behind is difficult to comprehend until you're standing in the middle of it. 73 Microsoft repositories disabled, taken down, compromised. The repositories affected include infrastructure connected to Microsoft Azure, to AI developer tools, to coding environments used by developers around the world who trusted that the packages they were pulling from official, verified, Microsoft-maintained sources were clean. They were not clean. And the reason they were not clean, the reason a worm named Shai-Hulud has been carving through the software supply chain since September 2025 and is still carving through it today, is a story about how the infrastructure that modern software is built on top of is fundamentally more fragile than anyone in a position of institutional authority wants you to understand. To grasp why this matters, you need to understand the scale of the system this worm is moving through. The NPM ecosystem, the package registry where this worm does most of its damage, hosts over 2 million software packages. These are not niche tools used by a handful of specialists. They are the building blocks of the modern web. When a developer builds an application, whether that application is a startup's product, a bank's customer, portal, a hospital's record system, or a government agency's public-facing service, they do not write every function from scratch. They assemble their application from packages, pre-built components maintained by other developers, pulled automatically from registries like NPM. This is how software development works at scale. It is efficient, it reduces duplication, it allows individual developers to build on top of work done by thousands of others. It is also, as Shai-Hulud has demonstrated with increasing brutality over the past 9 months, a system with a catastrophic single point of failure. If the packages are clean, everything built on top of them is clean. If the packages are compromised, everything built on top of them is compromised. Every application, every user, every credential, every piece of data passing through software that depends on an infected package inherits that compromise silently and automatically. The supply chain is the chain, and Shai-Hulud is a worm that learned how to move through every link of it simultaneously. Here is how the worm actually works, explained in terms that do not require a computer science degree to follow, because understanding the mechanism is what allows you to understand why this attack is so different from conventional malware, and why conventional defenses fail against it. Shai-Hulud begins with a single stolen credential, an NPM publish token, the kind of authentication key that allows a developer to upload new versions of their packages to the registry. These tokens can be stolen in multiple ways, through phishing, through compromised developer machines, through leaked environment variables in public code repositories, through the kind of careless credential handling that is unfortunately common in development environments that prioritize shipping speed over operational security. Once Shai-Hulud has one stolen token, it does not stop there. It uses that token to identify every package the compromised developer maintains. It then injects malicious code into each of those packages and publishes the poisoned versions to the registry. The malicious code executes during the installation phase of the package before any tests run, before any security checks fire. At the moment when a developer's machine or an automated build system pulls the package down and begins setting it up. At that moment, the code runs. It looks for NPM tokens on the newly infected machine. It finds them, it uses them, and the cycle repeats. Every developer machine that installs a compromised package becomes a new source of stolen credentials. Every stolen credential unlocks more packages. The worm does not need a human operator to make decisions. It does not need a command and control server issuing instructions. It propagates automatically, exponentially, through the trust relationships that developers have with the packages they maintain and the machines they use to maintain them. The original Shai-Hulud appeared in September 2025, and researchers at Unit 42 described it as the first self-replicating worm observed in the NPM ecosystem. A more powerful variant appeared in November of the same year, and imitators have since created copycat malware as the original spread across the internet. The most recent wave, identified by Microsoft Security Research on May 11, 2026, compromised over 170 NPM packages and 2 PyPI packages across 404 malicious versions, representing the first supply chain attack to simultaneously span both the NPM and PyPI registries in a single coordinated operation. And then, days ago, came the development that pushed this from a developer ecosystem problem into something that demands the attention of anyone who uses software built on modern infrastructure. GitHub disabled 73 Microsoft repositories after the miasma variant of the worm, a version publicly released by the group team PCP in mid-May, used compromised credentials to target AI coding tools in developer environments. Let that sit for a moment. Microsoft, the company whose software runs on 1.4 billion devices, the company whose Azure cloud infrastructure powers a significant fraction of the global internet, the company whose developer tools are used by tens of millions of programmers worldwide. 73 of their repositories compromised, not by a zero-day vulnerability in Microsoft's own code, not by a sophisticated intrusion into Microsoft's internal networks, by a worm that stole credentials from developer machines and used those credentials to poison packages that Microsoft developers maintained. The attack did not need to break through Microsoft's security perimeter. It compromised the humans working inside that perimeter through the same mechanism it uses against everyone else, and the result was poisoned packages in Microsoft's official GitHub repositories that any developer trusting those repositories would have pulled down automatically. The miasma variant has advanced data collectors specifically engineered for cloud identities in Google, Cloud Platform, and Azure, with a clear intent from the threat actors to leverage access away from the codebase and directly into live cloud environments. Now, let us talk about what the worm does once it is on a machine, because the credential theft and self-replication are the mechanism of spread, but they are not the full picture of the damage. The miasma Shai-Hulud worm attempts to steal credentials from password managers, including 1Password and Bitwarden, reads over 90 hard-coded paths to credential files for services including Amazon Web Services, and targets AI tool configurations. The worm targets Docker, AWS, Microsoft Azure, Google Cloud Platform, Kubernetes, and HashiCorp vaults, and spreads through two paths via AWS and Kubernetes to propagate into further non-Windows environments. The malware uses stolen cloud credentials to access cloud-native secret management services, while also exhibiting destructive code that wipes user data when it is unsuccessful in harvesting data. That last detail is important and underreported. When the worm cannot steal what it came for, it destroys. A failed infection attempt does not leave the machine clean, it leaves the machine wiped. The attack has two modes, successful exfiltration and scorched earth, and neither outcome is acceptable, and neither is recoverable without preparation. Between late 2025 and mid-2026, the operators behind it, tracked publicly as Team PCP and also identified under aliases including PCP-Cat, DeadCat-X3, Shellforce, and CipherForce, industrialized this model across NPM, PIPI, GitHub Actions, Docker Hub, OpenVSX, and IDE integrations. IDE integrations means the tools developers use to write code, extensions installed in Visual Studio Code, and JetBrains products in every major development environment. The attack surface is not just the package registry. It is every layer of the development toolchain, and the group behind it has been systematically working through each layer, with a patience and sophistication that the security industry has been chasing without catching for 9 months. And then came perhaps the most consequential development of all. The weaponized worm code was publicly released, making the full malicious payload available to anyone. This is the development that transforms Shai-Hulud from a threat operated by a specific criminal group into a threat that any actor with basic technical capability can deploy. The original developers open-sourced their attack. The barrier to launching a Shai-Hulud-style supply chain attack is now the ability to read documentation and follow instructions. Every script kiddie, every opportunistic criminal, every state-sponsored actor looking for a low-cost, high-impact operation now has access to a fully functional, battle-tested, self-replicating supply chain worm. The security community has a term for this moment. They call it commoditization. When a sophisticated attack becomes a commodity, the frequency of its use scales with the number of people motivated to cause harm, and that number is very large. Here is what all of this means for people who are not developers, because the instinct when reading about NPM packages and CI/CD pipelines is to conclude that this is a developer problem and not a personal one. That instinct is wrong. Every application on your phone, every web service you log into, every piece of software you use that was built by a development team using modern tooling was assembled from packages. The applications you trust with your banking credentials, your health information, your personal communications, your financial records are built on supply chains. Supply chains that Shai-Hulud has been moving through for 9 months. Supply chains that now include compromised components from 73 Microsoft repositories that were trusted by developers until days ago. You do not need to have installed an NPM package yourself for this to matter. You need only use software that was built by someone who did. Here is your action plan, organized by who you are and what your exposure looks like. If you are a developer, your actions are urgent and specific. The first thing you do is audit your NPM tokens immediately. Go to npmjs.com, log in, navigate to your account settings, and review every access token listed. Revoke every token you do not recognize, every token that is older than 90 days, and every token that has published permissions, and whose existence you cannot account for with certainty. Create new tokens, only with the minimum permissions required, for the specific task they are needed for, and set expiration dates on all of them. The second action is to audit every package you maintain. Look at the published versions of your packages and compare the code in the most recent published version against what is in your source repository. If there is a published version that does not correspond to a commit in your repository, that version was not published by you. Report it to NPM immediately using the security reporting process at npmjs.com and communicate to your package's users that they should not use that version. The third action is to check your development machine for indicators of compromise. The Shai-Hulud family looks for credentials in specific locations, including your home directory, your environment. Variables, your AWS credentials file at so.detomat.daws credentials, your Google Cloud configuration, your Azure CLI configuration, and your Docker configuration. Open each of these locations and look for recent modification timestamps that you did not create. Any file in a credentials location that was modified at a time you were not actively working as a red flag that warrants immediate investigation and credential rotation. The fourth action is to enable two-factor authentication on your NPM account, your GitHub account, and every cloud provider account you use for development, if you have not already done so. Shai-Hulud steals tokens, but two-factor authentication on account login does not protect tokens that have already been stolen. What it does is prevent the initial account compromise that creates the conditions for token theft in the first place. The fifth action is to review your installed VS Code extensions and any other IDE extensions you have installed in the past 6 months. The miasma variant and its descendants have been observed in IDE extension ecosystems. Check each extension against its publisher's official page to confirm the version you have installed matches the currently published version and that the publisher account has not been compromised. Remove any extension you do not actively use. If you are an ordinary user rather than a developer, your actions are different but not less important. The first action is to update every application on your devices right now through official channels only. Application updates delivered through official app stores and official update mechanisms will contain remediated versions as affected vendors. Push fixes. Updates downloaded from third-party sources or prompted by unexpected pop-ups in your browser may not be legitimate. Use official channels exclusively. The second action is to treat any unexpected credential prompts in applications you already use as potentially suspicious. One consequence of supply chain compromises reaching end-user software is that applications that previously did not ask for credentials may suddenly request reauthentication. If an application you use regularly and that you have been logged into for a long time suddenly asks you to log in again without an obvious reason, use a different device or fresh browser session to go directly to that service's official website rather than authenticating through the application that made the request. The third action is to check whether any software you use was identified in the affected repositories. The list of compromised packages and affected downstream software is being maintained and updated publicly at the GitHub Advisory Database, accessible at github.com/advisories. Search for applications you use regularly and check for any advisories issued in the past 30 days. The fourth action is to rotate credentials for any service where you use the same password you use for developer tools or cloud services. If you are someone who works in technology and has blurred the line between professional and personal credential hygiene, Shai-Hulud's credential theft targets developer machines, but the credentials it steals are used for personal services, as well as professional ones on machines where that separation does not exist. The Shai-Hulud story is not over. The ransomware group VACT announced a partnership with Team PCP, hinting at a possible shift from credential theft toward large-scale extortion and ransomware operations, and the May 2026 campaign offers the first concrete signal that this shift may already be underway. A worm that began as a credential stealer is evolving toward ransomware. The infrastructure it has spent 9 months building, the stolen credentials, the compromised packages, the poisoned development environments, the access to cloud systems across hundreds of organizations, is being repurposed for a different kind of attack, one that does not just steal quietly, one that locks, demands, and destroys. The 73 Microsoft repositories are not the end of the story. They are a chapter in the middle of it. What the next chapter looks like depends in part on how seriously the people and organizations affected take the steps available to them right now, today, before the next variant surfaces and the damage compounds. The worm is in the sand. It has been moving for 9 months. Now you know it is there.